Hello and welcome to DCG's development update. We are here today with the core, the platform, and our mobile teams. And we are planning this session for 1 hour, and we are planning also a dedicated Q&A session at the very end. If you have questions or comments or feedbacks, please use a Q or question prefix so that we will know in the live chat below that you want us to answer in the Q&A session, so that we will know that it is intended to that session. So a Q or question prefix to help us identify the questions. All right, without further ado, let's jump in and let's start with the platform teams.
You were very consistent every single time without further ado. I've noticed the past 7 times. I don't know. We'd have to check before that. Okay, let's go on. So an overview. So me, Ivan, and Lukasz working on platform. Lukasz was also working on TenderDash, and actually never mind. Strategy tests and platform TUI. Paul, Ivan did I think something there as well, and GroveDB was Evgeny and Odysseus. So we're gonna start this week with TenderDash, and we'll pass it to Lukasz. But before we do that, I just wanted to say that sadly Ivan is sick today, and we could have presented his work for him, but he did a lot of work on he actually has been reviewing. He's moved on to the review section of the code base, and yeah, he's spent a lot of time trying to find errors in our validation, writing a lot of tests. He will present that on the next sprint review, so he won't be present today. I just wanted to get that out of the way. But we have a lot to talk about on various subjects, and a demo to give. So it should be quite interesting. Okay, let's start.
Lukasz.
Hi. So I worked mainly on TenderDash this sprint. I was also off for a few days, but basically first item that I spent some time on, and it's in progress, trying to reproduce that reliably and fix, is some issue where single master node, not the whole network, but single master node might have a chain halt state because some votes are getting stuck for some reason, and the vote queue grows, and basically this node is not processing the votes, so it basically lags behind and never recovers until restart of that node. Of course, restarting helps, but that's not a solution. So I'm in the middle of debugging that. Another thing I'm working on is transaction gossip. So when we broadcast a transaction to a node, it's resending that, it's rebroadcasting it to other nodes, and we implemented some limits to limit performance, to limit speed of this gossip, of this broadcasting, just to protect our resources and have some strategy to process votes first and process consensus and generate new blocks before accepting transactions that were already put into some node. So that this is rate limiting, and right now we decided that it should be limited per peer, because what we have right now is just a global limit, like a node can get 100 transactions from that gossip protocol. Right now, we are changing it to, for each node, the limit is 10 transactions. Of course, just example numbers. We need to tune it afterwards. And another thing that is, I think, almost done, just needs some testing, is in some conditions when we replay transactions, when we replay blocks, when a new node connects and needs to process all past transactions, we might not have public keys available from other validators. And right now the code was that the code didn't allow that, and this change is aimed to allow validator information without a public key, because we still have a threshold public key that can be used to verify votes or verify information in the network. So we don't really need these individual public keys of individual validators. We just need that threshold key. And one change in configuration on seed nodes, we don't need ABCI configuration, so we don't need to configure drive connectivity because seeds don't have drive deployed at all. And it caused some issue when we were deploying, so we fixed that by just ignoring that section on seeds. I also did some improvements in terms of the testnet. So we worked on logging, and I participated with Vivek and Latte on that. We did some new policies of log rotation to not use whole disk space. And also we have some Grafana dashboards for testnet. And yeah, I also did some work on that to better visualize the status of the system. So for example, this is internal view. There's also external that we presented a few sprints ago. This is internal, mainly due to performance issues. So we can see that we have some alerts, and we can see which master node is not up to date. Basically, that chart on the left bottom part of the screen shows us which master node is not up to date when it comes to the most recent height. And it's all tender dash based, right? So this is tender dash view. We also have some capacity, some options to get statistics from drive. Ivan did a bit work on that, but that's not yet visualized here. But basically here we can just have a quick information if the network is up, if it's healthy, if it's advancing, how many blocks per minute we generate, and if the voting is going correctly. If we have the commit round bigger than 0, then it means that something got a bit wrong, maybe some network latency or whatever, and we might check that, but usually it's 0, but it's also visualized here. Yeah, so that's pretty much it on my side.
Thank you very much. So let's
Thanks.
spend the next 20 minutes explaining, demoing, and sharing updates on masternode voting. Sam, would you kick us off with that?
Yes. Why can I not find the way to show my video?
I can ask to start a video.
No. Wait. Oh, well, I can't find it. Okay, doesn't matter. So that's very weird. Okay, well, you can. There we go. There I am again. Sorry, guys. Yeah, so the master voting. Yeah, to give a quick summary, there's going to be like a 2-second quick summary. It's not done yet. And I'm going to explain today all the different components of masternode voting and what has been done, what hasn't been done. And I think people will understand the complexity here and like how much has been accomplished so far. So masternode voting can actually be decomposed into multiple subcategories. We have the vote structure, we have the contested, and we're going to go into each one of these. So, well, most of them today. We have the contested unique indexes and data contracts. We have contested document processing. We have specialized balances. We have masternode vote state transition and validation. We have masternode vote execution proofs and proof verification. We have the tallying votes and awarding the unique index. And we have queries that are available on the system. Okay, so where are we? Can we go to that side? And I can't actually even see the slide, so I guess we're at the next slide. So some of this has been done, some of this is mostly completed, and some hasn't been started. The vote structure is done, the contested unique indexes and data contracts is done, the contested document processing is close to being done, specialized balances close to being done, the masternode vote state transition validation close to being done, the execution proofs and proof verification is done, and the tallying votes and awarding unique indexes is not even started. We do use some trees for vote tallying, so we know immediately without actually having to query who's winning and who won, and there's a GoDB proof for that. But yeah, it's not started. It's not the biggest of all these things, but it's the last thing that would need to be done. And then we have queries that need to be written. So some of the queries have been written, some are in progress, and some haven't. Okay, so let's go in and kind of explain what is masternode voting. So masternode voting, vote structure. I hope we're switching to the next slide. I can't see anything.
Yeah, vote structure. We are at
vote structure
right now.
So when we think about a vote, the word vote in itself has a really big problem in English, because often when we say a vote, it can reference the whole voting process, right? Like there is a vote on September 15th, right? That would mean that it's not one person's vote. It would mean a vote, like a vote poll. So to make this system a little bit less difficult, we call one a vote poll and the other one a vote. A vote is just a singular vote that somebody has, and a vote poll is the contest, I would say.
The event of
the event. Darn English. Or maybe it's just me that doesn't speak English properly. And maybe there is better words for this. If anybody does know better words, please let me know.
Yeah,
so
let me just add one thing. These votes are a different thing than what I mentioned in terms of tender dash.
Oh yeah,
yeah. Just want to clarify that.
It has nothing to do with tender dash. These are specific votes to, well, I'll get into it. But let's start with basically saying that when you send a vote, like this is kind of just the vote structure. When you send a vote, the vote that you're sending is for a vote poll, like a voting event, and you have a choice. For the first version, the only types of vote polls that we're going to be supporting are resource votes. And the only type of resource votes that we're going to be supporting are contested resource vote polls. Contested resource vote polls are created, are created when inserting a document that is marked with a conflicting index. I'm going to get more into this and why this is important in the next few slides. So for when voting on a resource vote poll, You may abstain, vote in favor of an identity, or lock the vote. And this is actually quite interesting. So abstaining, everybody understands why you would abstain. Let's imagine two people want a specific name in the system. Like this is one of the reasons why we're making this feature, is to be able to distribute through voting DPNS names. But it's also like a very, very amazing feature to have anyways. So it's really cool. And I'll get into why it's really cool. But yeah, let's imagine you want to make a vote. What are you going to do? You're going to either vote for somebody. I mean, if there are different people that are all trying to get a same unique resource, you would vote either for one or the other. So that's basically towards an identity. You might say, you might abstain. And there's also this the case where you can vote to lock the vote. So like, let's imagine somebody puts out a name that is that we don't want to distribute, right? That could be many reasons why we don't want to distribute it. It could have like very bad connotations. It doesn't really matter. We're not trying to censor, but the point is the masternodes can vote to lock it. Like, for example, if somebody wanted to name something dash is the worst, right? Or something like that. People can vote to say, no, I don't want you to get it. I don't want you to get it. I want nobody to get it. It's just an option. So, yeah, so let's move on to what it looks like at the storage level. So I made a little diagram. This is actually one of my internal diagrams that I just use for myself. I didn't really have time to make it look very, very pretty. We can see that there are two types of vote polls. One is decisions. The other one is contested resources. Decisions won't actually be built out in V1. We're going to do that for V2. The contested resource, however, is being built out. It's close to being, it's what I've been working on. Inside of that, we have 3 areas. We have basically the votes that are held in contract-based queries. And this is close to mimicking the way that documents are stored in platform. But instead of documents, we store the votes towards the document that you would like to store. And we also store the contested document until a time that we can move it from this contested area of storage to the real document storage. An original version of this, and something that I had done wrong, was that I wanted to do it all in one storage area. And the problem with that is that queries, it just was getting too complicated. So instead, I created a new tree that was specific for contested documents, unique indexes. And yep, this is how it came out. So basically, we'll get into the different queries that exist. I mean, basically, there's a section on indate queries, and this allows the system itself to know when to stop a specific vote and to tally it and to distribute the unique index. The identity votes are just there so people know how they voted. Like, hey, give me the votes, my votes that I've done, or other person's votes, and you can see who voted what way. Okay, next slide. So taking a step back here, masternode voting and the contested indexes, like, what are we trying to achieve? Well, we're trying to, in this decentralized system that we built, platform, or evolution, we're trying to distribute a unique resource. I mean, that's what it really is. What is a digital unique resource? It's a set of properties that is unique for a document. I mean, in our case, it's basically this set of properties that is unique for a document, because our documents are basically how we store information in platform. for the most case, using data contracts. So when we it's kind of pretty awesome if you think about it, because you're creating these digital unique resources, and you need to find a way, if multiple people want the same thing that is unique, how do we distribute it? So when in the data contract itself, it actually, you have a field for, okay, I want this unique index to be contested under certain parameters, and I want this to be the resolution. So the resolution is basically, it's like the way of resolution. How do we resolve the contest? And for version 1, the only way that we're going to support is the masternode vote, but later there's a lot of other ways that we can think of resolving a conflict, a contested digital unique resource. You could have a contest, for example, right? If you think about it, how does Bitcoin do it for block generation? Well, Bitcoin does, hashing, right? Proof of work, right? But there are many ways. Okay, I want this. How do I get it? And in this specific case, it will be masternode, but later down the line, we're definitely going to think of other ways to resolve such things, such contests. So fields of a unique index can have field matches to indicate that a certain combination of the field matches makes the unique index contested. Okay, that's a little bit complicated, and I have an example on how that works. Let's go to the next slide. So, for example, for DPNS usernames, we can use a regular expression that says that usernames that have no numbers in them and are under 20 characters are contested. Yeah, so that's basically like just a regex, and that's on one field. You can, and in this case, quantum would be contested. Quantum 2 would not be contested, would not lead to a contested resolution. And, basically anybody can just add that. So you can mark in your data contracts the rejects that you want to say, hey, if what is in here looks like this, then it goes contested. But maybe if it's not like that, it doesn't need to be contested. Anybody can add anything. That's a sub feature. We have two possibilities. I forgot to mention it. We have a regex, and we also have a number type regex, like it analyzes a number, if I remember correctly. Like you can say like, oh, the first 30 are good, but then afterwards, or the first 30 are contested, but then afterwards they're not contested, stuff like that. And these field matches can be done on multiple levels of a unique index. So for example, if you have let's say you want to say that the combination of a type of car and a color of a car is unique in the system, and there can only be one, Highlander style. So, let's say a red Mazda, okay? There can only be one red Mazda. So in your system, you would basically put a field match on the car type, but also on the color. And it would basically say that if you could field match them together instead of just as one thing. So you could say that there can only be one red Mazda. Basically, I don't know how to explain it better than that, but you can do that. Currently, we only support AND in the field matches, and no OR support, because I actually started working on AND and OR support, and I realized it would take an extra 3 or 4 hours at least. And I realized, look, I don't think we need that for first version. So let us move on to pre-funded specialized balances. This is another big part of so by the way, that contested part is all done, right? That I've been talking about so far. The pre-funded specialized balances, it's mostly done. When we think of masternodes voting right now, right, in the they don't pay for their votes, right? You can vote this way, you can vote that way. It's not on chain on core side, but it's also you don't pay for it. In platform, we also don't want masternodes to pay for it because there's a few problems with that, right? Like, so Evo nodes get funds that they can then withdraw. Masternodes don't get funds. So masternodes don't actually have funds to vote, but masternodes do want to vote in the system. I mean, we want masternodes to be able to vote, not just Evo nodes. So they don't have any funds. But then if we were to force people to send money to masternodes to be able to vote on things, well, it's not very good for their privacy at all. And second, it's not, I don't think it would encourage a lot of people to vote, right? So instead, we're introducing a new feature called pre-funded specialized balances that are funded by the identity requesting the vote. So let's say I want a specific unique index, unique resource in the system. Let's say I want the name Quantum Explorer in the DPNS contract because that's going to be the first one that's actually going to use this feature. I am going to put money towards the future voting of masternodes. And the amount of money that I put, I forget exactly how much it is. We're going to have to figure that out in the next few weeks. But basically, it's the equivalent for every masternode to be able to vote and then change their vote an additional 4 times. So everybody, and masternodes will only be able to vote a certain amount of times per vote, right? Because we can't allow something that's free to go on again and again and again and again and again without and I also think that if you vote for something and you decide to change your vote and you decide to change your vote again and you decide to change your vote again, I think 5 times is enough. Like who really changes their vote more than 5 times? Other than, a potential attack on the system. So, that's basically where I fell on that. And when a vote concludes, the unused amount of the specialized balance will go to masternodes. And pre-funded specialized balances are being used here for voting, but they don't only have to be used for voting. I can easily see in V2 or V3 a platform when we have data contracts where the data contract owner, let's imagine it's a food delivery service or something like that, they put money in a pre-funded specialized balance so that anybody making an order to their system, let's say I want to order from my local pizzeria and I want to order pizza. Should I really be paying for making that order in the system, or should the company be paying? So I think it's the company that should be paying, and I think the company would be happy to pay for this. And so like these pre-funded specialized balances will basically serve that function. They will be money that's not in a specific identity, but that can be used if a certain set of events happen. And so I think this is actually a very cool feature, and I'm happy to see it being used for other things later. How am I on the 20 minutes? Where am I, Balash?
You already used it.
Oh, no. Okay. Well, I'm almost done. I only have 2 slides left, and I'll go quickly. Masternode vote state transitions. This is kind of just saying like where I am on the state transition. So what I've described up till now is pretty much only when you insert a contested document, right? I haven't really talked about and then you put your money away for it. Oh, also one last thing to mention, when you make the document, just to make sure that there's no confusion ever, in the document itself, you have to say how much you're putting away. It's not just automatically taken from your identity. I decided to make it so in the document field, it actually says, okay, I'm willing to do a contest for this unique index or unique resource, and I'm willing to put this much money towards it. So like that, if let's say the system ever were to change the amount that you would be deducted, you don't get into any surprises. So you actually say, hey, I'm okay spending 0.1 dash instead of it just taking a 0.1 dash. Okay, Masternode vote state transition. So a lot of work has been done here as well. The structure of the state transition of the voting, the transformer. So what is a transformer? It basically transforms the vote all the way down. Well, it first transforms it into an action. A state transition action is basically a grouping of operations, and then it transforms it into low-level operations, and all that is done. So, cool. The validation, however, is written, but I want to take a second look at it. I'm not really happy. I think there's going to be more validation that's needed. For example, verifying that the master node that's making the vote, we verify that there's enough of the pre-funded specialized balance, if I remember correctly. So that part of the validation is done. The signature verification is done. But there were a few other things that I wanted that I think are needed for validation there. In drive methods, we have the insertion in progress, the insertion of the vote into the state. Yeah, that's not done yet. The identity query references, as I showed before, that's to be able to query. If I remember correctly, I think I did that last week, but I'm not sure it's working. So we have to write more tests for that for it to be done. And the removal is not yet started. Removal is basically when we remove, like when a masternode is removed, like taken down, the vote should no longer work, right? Because otherwise a masternode could just vote, change itself, like the 1,000 collateral goes somewhere else, vote again, and continuously do that and again and again and again, and just be able to do tons of votes. So we have to basically remove people's votes if the masternode goes offline. Well, not offline actually. So there's offline, the votes still count, but if the collateral moves, then we remove the votes. So yeah, queries, masternode voting queries. These are the queries that we basically are going to support. We're going to get the identity votes, like for specific identity, like what votes does Balázs have? Is he voting for me? Are you voting for me, Balázs?
Always.
Oh, thank you. Get the current conflicting vote polls for contested unique index. So this basically is what can I vote on in the DFPNS names? Like, somebody wants me to vote for Suzanne. Somebody wants me to vote for Fluffy Pony. Somebody wants me to vote for, various names that exist out there. And we can all vote on them. You can query them and basically see which ones you want to vote on and which ones you're not. We're trying to make the voting super simple, so masternodes can do it just with very, very much ease. Get vote polls that are finishing soon. Yeah, like what's gonna close soon. And getting the tally information for a specific vote poll, like who is winning the specific unique index resource that's going on. The contract can also specify how long you want the vote to take place. But the minimum default is 2 weeks, I think. Or I think I forget. I think I wrote 1 week is the minimum. And for DPNS, we are going to use 2 weeks. So when you register, like if you were to say, I want the username Ryan Gull, then you would say you want that username, and yeah, you could start amassing votes for it. There's also a timeout for other people joining in, right? So I haven't really set this in stone yet. I mean, this stuff is still happening. But most likely, let's say somebody else wants the same username. They can only say that they want the same username in a time window at the beginning, right? So they couldn't 5 minutes before the vote ends say they want the same username and then have like 100 votes and just take it. So yeah, that is masternode voting where we are at. There's still a lot of work. I'm really hoping that I've been pushing myself very hard, and I really hope that I'll be done by it this week. But yeah, it was harder than I thought. When I got into specialized balances over the last 2 weeks, I was like, oh yeah, there's a lot more work than I thought. Okay,
There's
so
one more task
Yeah.
here in the other task.
other tasks. There was something that I noticed while I was working on this, is that we had a pretty bad inefficiency where the document creation, update, and deletion was fetching the contract from the state 2 times instead of once. And it was actually making the user pay for those 2 fetches as well. And a document fetch is not extremely expensive for a state transition, but it's still not like free. So I fixed this, and we only fetch 1 time. Not a very big task, but some easy to fix thing that. Oh, and there was actually another thing that I forgot to write in the other tasks. Also, the actions on a document, like adding and removing, have been made a lot cleaner. So before, because we used to have the JavaScript version, we used to have extra calls that we don't use, like add document in pre-serialized form. And those have all been removed because they should never actually have been used in the first place. So now it's a lot cleaner in that section. Okay, cool. Well, I don't know how long that took. Let's say it only took 15 minutes.
Let's say.
Okay,
All right.
let's move on to strategy tests.
Paul.
Yeah, thank you, Sam. That's interesting stuff. So yeah, I'm working on strategy tests, and I want to give a shout out to Quizzy, who the community member Quizzy, who has helped me to revise the strategy test usage guide. There were some steps that I missed and stuff, and he's been running some tests, some interesting ones. He tried running test from 2 different servers at the same time, which I haven't tried yet. Yeah, and he's just been pointing out some things that have helped me, you know, improve them in general. So that's really cool. And I think I saw somebody else was getting started, Herman or something, I think his name was. But yeah, I added better error handling in the strategy tests and fixed some 2 issues, one with the UTXOs and one with imports and exports. And but the main thing that I'm working on now is enabling so that we can run a month-long strategy test or a never-ending strategy test, basically as long as we want. And so yeah, kind of have been working with Ivan and Lucas to plan how to do that, figuring out, how much dash are we going to need, like test dash, to do all these state transitions. Where should we do it? What kind of issues we might run into. So there's some things I need to change in strategy tests, like we need to collect the results from when you broadcast state transitions. Sometimes they broadcast fine, but in the mempool they fail, and we don't know why exactly. So we need to like collect the results, like the responses from the servers, which is done, but that's kind of uncovered a new issue where if a transaction fails in the mempool, nothing is being nothing is being we're getting no response. So we need to look into that. That's kind of what I figured out today. Yeah, and also we thought that the transactions were failing in the mempool because they were probably like getting added to blocks in some, or like in a different order than they were being added to the mempool. So we thought that maybe there were a bunch of nonce errors, but I added like a mempool counter to limit how many transactions a identity has in the mempool at a time. And unless I'm misinterpreting, it seems pretty certain that they're not nonce errors. So I actually have no clue what the errors are, why they're failing in the mempool, but that's what we'll be figuring out in the next few days. And yeah, that's like one of the last steps for us to start this month-long strategy test. So I think that should be happening probably in the next, maybe this next sprint.
Thank you very much. Shall
Thank
we
you.
continue with Odie?
Yes. Hello, guys. So state sync feature, the basic implementation was done during this spring. Also, an optimization that I described already in previous presentations, the multiple subtrees syncing in parallel, it is also done. What is still pending to have the complete feature working is the final integration with ABCI. So this is currently in development. And also the next and final optimization that needs to be done. I mean, it's not a must, but it's good to have the checkpoint mechanisms. So the ability to resume a syncing from a particular point in case of failure instead of restarting the syncing from scratch. So as you understand, this is a good thing to have. So yeah, that's all from me. I was super fast, less than a minute, I think.
Thank you. All right.
It's not
Shall
about
we-
the speed.
I know.
Thank you for your brevity. Evgeny,
Hello,
hello.
I'm gonna share my screen because it's a demo time. I suppose you can see it.
Yes.
This small rectangle is actually a major update of Visualizer because now it is run inside the browser. And it means a lot for us because if one have a decent web browser and access to a must node, one can investigate what's happening inside of GroupDB, just like that. And yes, and to add updates, we have now on-demand loading. So still in the web browser, we have a root node of the platform GroupDB, and we can fetch just one subtree because on previous demo, as you can remember, when there are lots of subtrees, it's kind of messy on the screen, and if subtrees are large, it can even hang the application. So now we have controls to choose which things we want to see and load them accordingly, like fetch only root of this subtree. 32 is a subtree for identities for the sake of the context. So when we loaded a root node, we can go to the Merk view, a view of a binary tree, because it's a GroupDB still, and subtrees are trees. And we can investigate further in more detail, who's on the left, who's on the right, and yeah, just like that. And all of these nodes are loaded on demand. So there are no whole database in my memory right now, in the memory of the browser process. I mean, and if the session is long and maybe you have a computer with small amount of RAM, a subtree could be unloaded to free up the memory. So yeah, also updates on in terms of alignment. As you can see, I don't move anything. It's just aligned by itself, depending on the context, contents, sorry. And it also goes to further levels. And now we can see new arrows here because some subtrees can have many keys, and to fit them on the screen, the pagination. So simple UX things you expect on any graphical application, but we didn't have it now before. Now we have, and it can go as deep as one need.
So cool, so cool. I
Now
mean,
we have it.
I find this amazing. It's going to be, can you go down do you have any data contracts?
I don't know. I think not. It's just a platform that was initialized locally, and I took the database from it.
No, you should. You should have the system contracts, I think. Where are data contracts again? I think they're in, well, they're in the root tree. So if you actually, can you look at the root subtree on a Merk level?
Yeah, let's do that. Okay, let me. Oops, fetch all. Let me close others because. Okay, so we have this one on the root, and okay, let's start. Where do you go?
So 64 is actually, just for having people, for fun, right? This is just fun right now. 64 is contracts. Actually, I'm going to bring it up. And I'm going to actually make sure that what you have is what we're supposed to have, because there's actually a specialized thing for where is it? Paths.
Okay, if you want to go 64, go
Okay,
it's
wait.
another subtree.
Okay, so at 64 is supposed to be data contracts and
Okay,
documents.
let's fetch it. There's
Yeah.
something.
There is, okay.
Maybe.
But I
strings.
wanna first well, you know what? What we need to do for next time is for drive specific numbers, we should just put what they mean.
Yes, also planned in a
Yeah.
backlog.
Yeah.
One thing at a time.
Well, no, these are contract IDs, so they're real. That you can do it in hex. Or
All right.
yeah, so but then you can go into one of these contract IDs. Let's say.
All right.
You can go into one, yeah.
So it has key 0 and key 1.
Yeah.
Yeah, what is on the 1?
What? Yeah, so just so people know, at 0, we store the data contract as an item. And that is where the data contracts are actually stored. And the visualizer is showing all of this. It's really cool. And Balash is thinking, oh, when should I stop their geeking out? No stopping our geeking out. Don't do it, Balash. Don't do it.
I was about to do it.
Yeah. But we're almost done. So you can see, and on the right side in the 1, we actually have the secondary indexes here. So on the right side, if you were to go into 1, are we into 1 down here?
Yes, subtree and the 1 is here.
Okay. And if we were to take switch this into ASCII below.
ASCII
in 1, yeah, down here, 100, 119, 105.
Withdrawal. You have a name.
Oh, yeah. So, I'm watching on YouTube. It's 30 seconds delayed. That's why I was so confused. Anyways, yeah. So withdrawal. So this is basically the withdrawal contract. Isn't that cool? And this is the withdrawal document type inside the withdrawal contract. And if you go further down, you're going to find the unique indexes for this and all the specialized queries that you can do.
And then,
so it's really like you can start exploring the magics of platform. And in my opinion, we should get in contact with the developer of Platform Explorer, Przemek, and ask him if he wants to put this eventually in one of his tabs on the Platform Explorer, because I think a lot of people would like it up there, like an easy access instead of making like another website. Maybe we just have it all as one. Anyways, very cool, very, very cool.
thank you.
Thank you, Evgeny. All right. Let me reshare my screen. And shall we continue with the core team?
Alrighty, sounds good.
Alrighty.
Thank you, Paul. We can move forward. So we did make some decent progress towards backports in this past week or past 2 weeks. Primarily a lot of refactoring in some of our P2P logic. Right, one of our major goals with version 21 is the version 2 P2P protocol, which enables peer-to-peer encryption. And so all traffic between peers would be encrypted. One of our major difficulties with doing that at this moment is we implemented some additional support in Dash for more efficient polling methodologies, specifically ePoll and KQ, that actually Bitcoin never had. Bitcoin doesn't really have or didn't have a large volume of messages between peers like masternodes do. And so this was something that we had to implement during the implementation of long-living masternode quorums and large quorum-based instance ends. So a part of our implementation moving towards version 2 of P2P is refactoring how we're handling stuff like ePoll and KQ. And so we kind of have to move it out into different spots of the code base. So it's taking a little bit longer than I was hoping for, but Kitty Whiskers made pretty solid progress on that in the last 2 weeks, and we're moving forward towards being able to continue backporting version 2 P2P. In other news, Constantine is starting to work on work in progress hardware wallet support. This is something that Bitcoin added not too long ago, and it looks like this should be relatively easy to backport. We're also continuing to move forward with trying to require C++20. That'll enable a lot of better kind of coding practices and make life a lot easier for us, but we're having some issues with it right now with some of our dependencies. So I'm still trying to work through that, but otherwise moving forward with backports and everything like that. I think we can move forward here. About 153 Evo nodes now. Basically everyone's on version 20 for masternodes and about 40% on version 20.1. We can also move forward here. And just briefly, here's the list of PRs merged recently. Yeah, not quite as many as I was hoping for, but a number of them are pretty substantial and have a lot of kind of complex stuff going on. Yeah, that's about it. We can move forward to mobile.
All right, thanks, Pasta. So, yeah, we were blocked in a couple different areas on Android, but we did finish the fetching of identities and started work on document object support and fetching documents. Those were pretty much kind of on hold until some of the other macro work and ferment work was being done. We started working on or implementing a warning when there's a problem with the rate service if the rates are stale. The mainnet testing of CoinJoin was done, so we'll be putting out a release to our community to play around with that on mainnet. And then Maya submitting transactions and error handling was in testing. Move on to the iOS tab. It was a pretty hefty sprint for iOS. We had a few different pieces of Rust work that carried over a couple sprints, so we managed to kind of wrap those up and break apart the things that still needed to be done. First of which was smart pointer support and external crates. On Dash Wallet, we had a crash fix, and then the syncing status that's shown on the home screen, it was a bit confusing, so we separated or removed really the status that's shown for rates, so it's just now showing status for chain sync to avoid confusion there. And then we wanted to store the rates in cache a little bit differently and to prepare us for that same stale rate warning that we just did on Android. And a lot of good work on CoinJoin was done as well. That pretty much covers us on mobile. We are still working with the Apple Store on how we have Coinbase features implemented on iOS. Because of the UK regulations, we currently are hiding that feature for UK users, for users in the UK storefront. They wanted us to go a step further and avoid the use of those features for any user in the UK, regardless of whether they got the app from the UK storefront or not. So we're trying to work on that as a hopefully a temporary measure to get past the APA guidelines, or to be in adherence to them. In parallel to that, I'm also working with Coinbase directly and their partner in the UK to see if we can get kind of, I'll call it inherent approval through Coinbase, so that we don't have to hide the feature, and we can just be abiding by their guidelines that they need. So that's a work in progress as well. That's it for mobile.
Thank you very much. Let's start with the questions. I guess CoinJoin, when CoinJoin in mobile is answered by you, Brian, do you want to add anything else? We have this
well, I guess
when we will have CoinJoin in mobile. That was a question.
Right. So that can be answered a few different ways, I guess. The update I just gave for Android was, we're opening, I'll call it alpha. It's technically probably more of a beta now that it's on mainnet, but testing of this CoinJoin feature on Android. So that's going to be coming out this week in the next day or so. And on iOS, we still have probably around about a month or so of development. And then we can start into our own internal testing. It's pretty much been mostly all back-end development work that's been done so far on iOS. So once that work is all done, we'll get into the actual front-end testing of it. So we could be looking at another month and a half before users start seeing anything on iOS.
Yeah. Sam, when Evo, when tokens? Sam, do you want to handle that? Give your thoughts on it, if you can. If you find the unmute button.
Oh, sorry, I was speaking to myself again. Sorry. Yes. So when Evo, when tokens? This is very good questions. Well, we're not there yet. We can basically see that. We're not there yet. Why are we not there yet? While like things are coming together and more is coming together, we're not done with the mass node voting feature. And it was after the mass node voting feature was done that I was going to, start to think about like when was going to announce, like basically take all this work left that we can think of, see, oh, is this a week or two, or is this a month or two? Like, and to be able to give like an actual official timeline for Evo release. We're not there yet. Probably, hopefully we'll be there in 2 weeks from now. With mass node voting being done. And then, at that point, gonna start maybe take a day or two to update all of our roadmaps and start planning for the mainnet release.
You want to address the when token questions?
Yeah, the when token. Tokens are not very complicated. I really didn't want to get distracted since I'm writing these features. And like, Quizzy, who's watching right now, was like, when masternode voting, when masternode voting. So like when tokens is one of those things that maybe I'll do on a weekend if I can, right? But since it wasn't part of V1, I don't feel like it should come out of my work hours. I'll do it on top if I have a weekend where I'm not doing anything and mass node voting is done. And yeah, so that's basically the answer. Hopefully we'll get it into the first version.
Thank you. Next question is,
yeah,
thank you. How many transactions need the testnet of platform to launch in mainnet?
So for V1, we're going to be okay with anything above 50 transactions per second. For V2, we're going to up those numbers. I mean, basically, I'm going to write this down on the roadmap. There's a lot of optimization that's possible that we're just not doing right now. But I don't want people to think, oh, this first version, it's not optimized at all. It's like, it's a mess. No, that's not the case at all. What we've actually accomplished here is pretty fast considering. And one of the reasons why it's fast is it's written in Rust. The memory management is very, very good. However, why do we only get a certain number of transactions per second? Like at the moment, we're getting around 60. Well, it's mostly because of each transaction can represent like 40 operations on between like fetches and reads, and there's a lot that goes on compared to transactions that just would like be executing in a virtual machine. There's a lot of IO operations that happen in sequentially, and this all takes time. And since the whole block propagation happens sequentially, yeah, we don't get that many transactions per second. But for the first version, transactions per second is not really the goal. The goal is to get something out there that's stable. If we have a problem and we're getting more than 50 transactions per second, that would be crazy good. For the first, I mean, this is just for the first few months until we get V2 that will have a lot of optimizations. For V2, my target goal is basically we're going to try to double it every single time. So for V1, whatever we end up at, I mean, right now we're between 60 and 70. What is acceptable to me is as long as we end with over 50, that's fine. And we've seen up to 90, but that's, you know, depending on hardware, etc. For V2, we're going to double whatever we release with, and then we're going to try to double every single time. There are so many different optimizations that I can think of that will severely impact speed and how many transactions we can have. Parallel processing will take it through the roof once we finally get around to that. So I could see us having, like, if we focused on all these optimizations and instead of just getting the system out, and if we spent like 4 or 5 months on it, just optimization, I could easily see us going up to 1,000 transactions per second. Not easily, with a lot of sweat and effort, but I think we could get there. But yes, you know, for the first version, not having a crazy high amount is acceptable.
I'll ask the master node voting part of the presentation, the master node voting part of the presentation, that did I miss it? Is it simple majority for distributing doc or not distributing, and does tie go to no one?
So actually, on the part where for the vote finalization and distribution, that's not yet done. So that's why you didn't miss it. I haven't really thought about it yet, because I've thought about it a little bit, but I haven't gone deep into it. In the event of a tie, it will be the first person who did it, like the first of the two, right? So if like 2 people both get 300 votes, whoever was the first one would receive the item. What was the other question?
Was it simple majority for distributing doc or not distributing? Yeah, I'm not sure I understand it.
Oh, no, it's whoever gets the most votes. In this case, you don't need over a certain threshold. So if you even have 0 votes, if you were the first one to want it, you would get it.
Right, next question is, how will master node / Evo nodes know there is a poll that they need to participate in through a dApp or through a terminal interface or something else?
So what DCG is gonna provide for the release is the ability to do this through iOS and Android, at least for DPNS polls. I'm not sure if for every poll there, and and also in the platform TUI for more advanced users who want to maybe do it quicker. But I have a feeling that other networks other projects like Dash Masternode tool and maybe others on our network that where you have maybe Dash Central will maybe we can tell him, hey, you wanna implement this feature? It will be cool. But currently, yes, from DCG's side, iOS, Android, and the platform like the TUI.
More questions. Let's just go through them quickly, briefly. When will NFTs be on Dash platform documentation?
Good question. I do not know. Jeremy. Yeah, I don't know.
We will get back with an answer.
We will get back.
Could you explain how network will handle protocol upgrades? Right now, testnet is being wiped on each breaking change in platform. Will be there a mechanism like in core where all hard forks specified in the code, and how far we are from not wiping testnet when deploying breaking changes in the network?
Yeah, so the the problem is actually that this is also kind of called voting, right? It's voting for a version change. So that's all been built out and that all works. We've never, I mean, we have tests that show it work. We've never done it live on testnet. We do plan to do that before release on a 2 or 3 day test where we change versions where different people vote for like the Evo nodes will vote for a new version, and we will switch on the hard fork. We've done tests, but they've been small tests, and they've been, I mean, it theoretically should all work. So there's really no problem. The reason why we wipe every single time is because when you write when you write code in the new format, you have to keep all the old code behind, right? So everything that worked in the past must always work, because you should always be able to replay blocks. But because we don't want a tremendous amount of legacy code, we don't keep what didn't work in the past, right? Because it was never released. So that's why we wipe every time, because we're not doing the upgrade process and writing like new functions when we're changing things. We would, I mean, but all of this should work and has been tested, and we have tests in the code base. So, but until the very end, we're going to continue wiping testnet because we don't want to keep legacy code that never hit mainnet in the code base.
All right, we ran out of questions. thank you for your enthusiasm and with the questions and feedbacks. Thanks for being here, and see you in 2 weeks. Thank you. Yes. Bye-bye.